Greetings! NASA issued a statement on its Artemis blog Tuesday evening outlining some of the decisions leading up to the next launch attempt. There has not been a briefing to the press about these decisions yet. Managers have elected to replace seals of the leaking hydrogen disconnect in the tail service mast umbilical, TSMU, on the pad, permitting a mini wet dress rehearsal confined to the core stage hydrogen system. By subjecting the disconnect to the same cryogenic hydrogen flow as the real countdown, it will be possible to verify whether or not the large leak seen on the second launch attempt is fixed. The seal repair will require technicians to set up an enclosure around the umbilical to provide protection from the elements in a nitrogen purge environment. The statement gave no indication of how long the process to make the enclosure will take or when the repairs might be completed, which would then be followed by the cryogenic flow test. An additional task involves checking plate coverings on other umbilical interfaces to assure that they won't leak. The statement says, with 7 main umbilical lines, each line may have multiple connection points. This issue had not been raised by NASA managers in earlier briefings. A cryptic comment in the paragraph about the repair leak said, teams may return the rocket to the VAB to perform additional work that does not require use of the cryogenic facilities only at the pad. We don't know what they are referring to here. Is this in reference to the hydrogen leak or some other issue? We do know that the program has acknowledged a potential safety of flight issue regarding the foam insulation crack on the inner tank flange. Manager Mike Serafin has stated that it could lead to a liberation of foam, which might strike a solid rocket booster separation motor. The threat was characterized as being very small, but no hard data was provided. Serafin said the program accepted some elevated risk. Obviously, if the motor should sustain enough damage to prevent its proper operation, it would cause a catastrophic accident. The location of the flange precludes repair at the pad, but it is conceivable that workers might gain access to the flange in the VAB and patch the crack, something that was done in the past on the Space Shuttle external tank. The elephant in the room is the status of the rocket's Flight Termination System and questions about the certified longevity of its batteries and circuits. When it left the VAB, the system was certified for 20 days. In order to open up the early September window, NASA asked the Range Safety Authority for this launch, which is the Space Force's Space Launch Delta 45, for an extension, and they were granted 5 additional days. Now, NASA has gone back and requested a much longer extension to permit attempts in the opening days of launch period 26, commencing on September 19th. A response is anticipated in the next few days. If NASA gets the extension, an expeditious pad repair and hydrogen flow test might be done in time for the late September window. This would see the rocket stay on the pad and not roll back to the VAB. In this scenario, NASA would be sacrificing whatever unspecified additional work they were referencing in the blog post, plus the potential opportunity to deal with the safety of flight insulation crack. The first 5 September windows are at night. The 19th is unlikely to see an attempt, as the window was only 17 minutes long. The window on the 20th is 67 minutes, followed by 112 minutes on the 21st. There are 5 windows lasting 2 hours, starting on Thursday the 22nd, with the first ideal window featuring daylight on Saturday the 24th. Quite frankly, the public has been given inadequate information about the rationale driving the FTS certification decision process. We know virtually nothing about the system or why its battery life is so short. Even the language used about the VAB work has been confusing. Reset, retest, perhaps recharge or replace. Does the issue involve battery voltage? Isn't the voltage being monitored? What other factors are being evaluated? The integrity of the destruct system is of paramount importance to public safety, especially given the power and size of a rocket dubbed the Monster by Senator Administrator Bill Nelson, performing what NASA declares as a test flight. We already know of one potential flight safety risk, the foam strike threat, that will not be mitigated if they fly this month without a VAB rollback. And there is the persistent talk outside of NASA about the longevity of key solid rocket booster safety items, such as the segment joint O-rings, which may not have been initially certified for the prolonged duration of this launch flow, or the repeated trips to and from the VAB. Questions about these risks have generally been deflected during press briefings with non-specific assurances. The Space Force Range Safety Office takes its responsibility very seriously and has an impeccable track record protecting the public from rocket accidents. It is currently headed by Brigadier General Stephen Purdy. In asking for the FTS extension, NASA might be exposing the agency to the perception that schedule pressure is leading to the acceptance of unnecessary risk. It's quite likely that NASA has good evidence to support their request, but we just don't know. And a typical public reaction when initial standards are waived is to suspect that a greater risk is being incurred. Since we are not privy to the technical information needed to assess the FTS system certification, we need to trust that Go Fever is not endangering the public. If the extension is granted, the public should be given enough facts to understand the rationale behind the waiver. The CubeSats also face problems with the age of their lithium batteries. Observers have expressed concern that the batteries may lose enough charge to prevent the little satellites from operating after they are released from the SLS rocket. We have new information, however, that allays some of those fears. A principal investigator for the LunaMap project has provided a thorough explanation that answers many questions about the CubeSats, and we have the details.
The 10 CubeSats carried inside the Artemis 1 rocket have generated considerable interest and concern about their batteries. When Artemis program officials have been questioned about them, the answers have been less than complete. Planetary scientist and lunar polar hydrogen mapper principal investigator Craig Hardgrove of Arizona State University provided an excellent report on the power situation in a series of tweets, with the best explanation we've seen. He provides hope that the launch delays will not automatically endanger these fascinating and pathfinding missions. His views are his own and do not represent NASA or the SLS program. Here is some of what he said. Thanks for thinking of us little guys. The CubeSats were delivered to KSC in July 2021. Each uses the same type of batteries, lithium-ion 18650. Each CubeSat has a different number of them and were charged to different levels depending upon mission requirements and individual design specifications and decisions. Each mission requires a different amount of charge on the batteries in order to boot the spacecraft and begin operations. Each mission measured the rate of self-discharge on their batteries at some point prior to delivery, and most were consistent with rates around or less than 2% per month. There are several unknowns, however, provided that some missions charged to 100%, and the CubeSats have been stored in the rocket under ambient conditions without temperature control. Both of these incur an unknown penalty on the monthly rate of self-discharge. If the rate of self-discharge stayed around 2%, then, at least for LunaMap, the batteries would not drop below the minimum required to boot the flight computer and deploy the solar arrays until about 30 months after delivery. If, however, the self-discharge rate went up to 5% per month, then LunaMap would drop below the minimum required to boot in about 12 months after delivery. Without access to the spacecraft, each CubeSat program is doing their best to assess the risks to their mission based on the possible charge states after over 1 year in storage. Many assumptions are required and each mission is assessing the risks given their requirements. To be clear, the SLS program is doing everything they can to provide charge to those CubeSats that are able to charge their batteries. For those that cannot, the only way for them to be charged would be to remove the CubeSats from the Orion stage adapter, which requires destacking Orion. 5 of the CubeSats on Artemis 1 are unable to charge their batteries. The reasons why vary across the missions. Some did not design that capability, some decided not to, and others were not allowed to, due to SLS safety concerns. Luna Map is one of those that cannot. Upon deployment, all the CubeSats use solar panels to charge their batteries and/or power their subsystems. In the case of Luna Map and CUSP, they were designed so that if sunlight hits their solar arrays, the batteries will charge even if the spacecraft has not booted up. If these CubeSats deploy below the minimum state of charge, then any exposed solar panels will charge the batteries. Each mission is planning their post-deployment operations differently, based on their expected state of charge and their overall mission design. The CUSP mission, for example, is planning a long wait before their first DSN contact to ensure they are sufficiently charged. Luna Map needs to execute a set of propulsive maneuvers shortly after deployment, so a DSN contact is planned early on. With only one of Luna Map's 8 solar panels getting sunlight, if power is low, it may take a few hours to reach the required charge to boot, or not. How long it will take to charge sufficiently will depend upon the current battery stage of charge, which is not known with much certainty. We might be fine or need to wait. The time it takes to charge and get into a safe configuration will be a risk for each mission, but SLS launch delays do not mean that the CubeSat missions are dead, as long as they were designed to charge after deployment when their solar arrays are exposed to the sun. For these missions, like Luna Map and CUSP, possibly others, it just adds some risk. For Luna Map, if launch is after December of 2023, we can be pretty sure we will need to spend a few hours, up to a full day, charging after deployment. But the uncertainty about our rate of self-discharge means we could reach that point as soon as fall or winter of 2022. Deploying below our minimum charge to boot would be a very big risk to our overall mission success because of how little time we have to commission spacecraft subsystems and execute a lunar gravity assist with our propulsion system post-deployment, which is about 3 days. So while there is increased risk to the CubeSats who cannot charge, at worst they will deploy into a dormant state and spring to life after some sun hits their solar arrays. The biggest risk to the missions then is lost time. The interaction of some of the smallest interplanetary spacecraft ever built with one of the largest rocket programs ever has been very interesting and groundbreaking. Accommodating tiny high-risk, high-reward spacecraft on big missions will enhance big mission science. Little spacecraft can collect hard-to-reach but exciting datasets. How big missions accommodate tiny ones is a problem worth solving, and it doesn't have easy solutions. Tiny spacecraft are designed to different sets of requirements than bigger ones, and rockets. SLS has done a great job of working with all of the different CubeSat teams, and we are still in a position where we can achieve mission success. Of course, there's always more to learn, but considering we are all doing this for the very first time ever, I think we have set out on a good path forward, demonstrating we can work together. Let's go to the moon and beyond.
NASA's Exoplanet Archive says 17 new planets have been discovered by the TESS mission in the latest weekly report. The most notable is TOI 1452b, a super-Earth orbiting a red dwarf star about 100 light-years from Earth that might be covered by an ocean. We reported on that discovery last week. Overnight, the Air Force conducted the second Minuteman III ICBM flight in the last month. The missile was launched from a silo at Vandenberg Space Force Base. Here is a Space Force report.
Air Force Global Strike Command airmen conducted an operational test launch of an unarmed Minuteman III ballistic missile September 7th to demonstrate the readiness of the U.S. nuclear forces and provide confidence in the lethality and effectiveness of the nation's nuclear deterrent. Today's test launch used a randomly selected intercontinental ballistic missile pulled from F.E. Warren Air Force Base in Wyoming. The missile was transported more than 1,300 miles and reassembled at Vandenberg Space Force Base, California. The ICBM was equipped with 3 test re-entry vehicles and traveled approximately 4,200 miles at a speed of more than 15,000 miles per hour to a test range near the Kwajalein Atoll in the Marshall Islands. The ICBM Test and Evaluation Program helps validate the reliability the nuclear umbrella our allies and partners rely on, eliminating the need to obtain their own nuclear weapons to counter potential adversaries. The 50-year-old Minuteman III is based in Colorado, Montana, Nebraska, North Dakota, and Wyoming, and will be replaced by the LGM-35A Sentinel. Reporting from Vandenberg Space Force Base, I'm Farrah Kaufman.
As of now, Saturday and Sunday might each have 2 launches or launch attempts. A brand new rocket from ABL Space, the RS-1, is set for its debut launch from the Alaska Pacific Spaceport Complex at 6 p.m. Eastern. The company suffered a failure in January of their second stage during testing in Mojave, California, and completed a first stage static fire in July. Given the fact that this will mark their first launch attempt, delays are likely. Up next will be a Falcon 9 Starlink launch with the Hitchhiker AST Space Mobile's Blue Walker 3. Launch from KSC Pad 39A is planned for 7:51 p.m. Eastern. SpaceX will continue their astonishing launch rate with another Starlink launch almost 24 hours later on Sunday at 8 p.m. Eastern from Pad 40. Also on the agenda for Sunday at 6 p.m. Eastern, the second test flight of the Firefly Alpha rocket from Slick 2W at Vandenberg Space Force Base. NanoRacks used the CubeSat deployer sent to the ISS with the SpaceX CRS-25 mission in July to successfully deploy all 5 of its satellite payloads. Their self-contained deployer, NRCSD, has been flown since 2014, and this was their 23rd mission. The NRCSD consists of anodized aluminum plates, base plate assembly, access panels, and deployer doors. The NRCSD deployer doors are located on the forward end, the base plate assembly on the aft end, and the access panels are provided on the top. The inside walls of the NRCSD are a smoothbore designed to preclude hang-up or jamming of the CubeSat appendages during deployment. BeaverCube is a 3U CubeSat from MIT demonstrating a small sat propulsion system and obtaining weather measurements with a small imager. CapSat-1 is a 1U CubeSat from a middle school in Florida, the Weiss School, validating the usage of capacitor technology as an alternative to lithium-ion batteries. CLIC-A is a 3U CubeSat from NASA Ames in partnership with Blue Canyon Technologies and MIT, demonstrating optical laser communications from space to ground and ground to space. D3 is a 2U CubeSat from Embry-Riddle and the University of Florida. This CubeSat is testing devices to control the deorbit of future CubeSats. Finally, JAGSat is the first CubeSat built by the University of South Alabama. It will study plasma in the Earth's atmosphere. For your Thursday, it's National Ampersand Day. And that's the way space is today. Until tomorrow, add in Explorata, toward the unknown in the measureless arena of space. Stay tough and competent, and thanks for watching.
Finally, an update for Wall Street, with the Nasdaq 100 index up over 2%. Traders were encouraged by a decline in Treasury note yields and favorable comments from Cleveland Fed President Mester. Our space stock watch list is green, with all but 4 posting gains. The biggest winners were Rocket Lab, which will make the Global Star satellite buses involved in the Apple phone announcement, and Ball Corporation. AST Space Mobile took a 7% hit. Reporting from cyberspace, this is correspondent Karen Calvis.